All right, so go ahead and verify this integral. All right, so start by taking the derivative of this. So let's take the derivative of this part first. All right, and if you got sine x plus x cosine x, good job. All right, so next let's take the derivative of this. Let's just take the derivative of this whole part right here, right? Good, and if you got negative sine, and this turns to 0, then you're right. All right, and so simplify this, and what do we get? Good. These sine x's cancel out, and you end up with x cosine x. So does it check out? That's right, yeah. This equals our integrand, and so therefore it checks out, right? So this is true. So that's a way you can always check your work, is just by deriving what you get for your integral and seeing if it equals your integrand. All right, so properties of indefinite integrals. So sum and difference is same as before, right? The integral of a sum is equal to the sum of the antiderivatives, or the sum of the integrals. And the same thing if we have a constant, right? So a constant, if we have the integral of a constant times a function, that equals a constant times that antiderivative, okay? In other words, you can just bring this out to the front and just derive anyway, and then multiply by the constant at the end, okay? So similar to derivatives, similar to limits, those rules apply. All right, so let's try some integrals here. So this first one, we're taking the integral of this polynomial, and so let's go ahead and do that. All right, so first of all, here I'm going to do one at a time, right? We're using the sum property, so we're just going to take one at a time. So here I'm going to add 1, so that becomes x to the 4th, and then I divide by 4, right? So it'll be 5/4 x to the 4th, okay? Here I'm going to add 1, so I get negative 7 x cubed, and then I'm going to divide by 3, right? So it'll be 3 there. All right, here I'm going to start with the invisible 1 there, right? So I'm going to add 1 to that, so that becomes x squared. And then I'm going to divide by 2, so 3 divided by 2 is 3/2, right? Okay, and finally I have this constant. So the integral of a constant, I'm just going to tag an x on it, right? Because remember, this was x to the 0 power, so I add 1 to 0 and I get 1, right? And then I divide by 1, and anything over 1 is itself. That's basically how that works. Okay, and then don't forget to add a constant, and there's our result for this first integral. All right, the second one, a little bit tougher right here. We have a quotient. What I recommend that you do with b, let me bring it down here, is to split this up. So I'm going to, because we don't really have a quotient rule for integrals. There are different ways we could approach it, but for right now, let's just split this x up. So it's going to be x squared over x, right? Let me just do it this way real quick. X squared over x is just 1x, right? And then when I do 4x to the 1/3, I'm going to make this x to the 1/3 power, right? Just change it to rational exponential form over x. So basically what we're doing is we're subtracting. 1 minus a third is 2/3. So I'm going to make this x to the negative 2/3, okay? All right, because remember it's a 1 in the bottom, so it's a 1 minus a third if you bring your x's to the bottom. All right, then I'm going to put the 4 here as well. All right, so then I'll put dx. All right, so here, remember there's invisible 1, so that's going to be x squared, and then I'm going to divide by 2, right? Divide by the exponent. This next one, I'm going to have 4x. I'm going to add 1 to negative 2/3, which would be positive 1/3, and then I'm going to divide by 1/3, right? And dividing by 1/3 is the same as multiplying by 3, right? So I'll put divided by 1/3, but we'll really just multiply the 4 by the 3. And then we'll put plus c, And so then we get x squared over 2 plus 12. And then I'm going to change this back to radical form since that's how we started out. So it's going to be cube root of x. All right. Now remember, if you're ever not sure, you can always take the derivative of this and see if you get back to what we started with. All right, and then I'll put plus c, and that's it. All right. So this next one, this is a inverse trig function. This is actually a tangent inverse, but yeah, that's one that we have, and we didn't get into inverse trig. I think I showed you what those derivatives are, but anyway, this one's not too hard. It's really just for tangent inverse or for arctan, but yeah, we're not going to worry about that. All right, and then here, this one's a little tricky too, but we can use a trig identity because remember that tangent is sine over cosine. So if we multiply sine over cosine by cosine, we just get sine. So this is the same as the integral of sine of x dx. And the integral of sine is negative cosine plus a constant. All right, so that's how we do those. And yeah, so let me know if you have any questions. But so basically we're just doing backwards derivatives, right? We're just kind of undoing derivatives. And that's what an integral is, or an antiderivative.